There are different kinds of metamorphism, different settings where metamorphism occurs. We'll go through each of these separately, but to begin with, there's thermal, burial, dynamic, regional, hydrothermal, subduction, and shock. Thermal metamorphism is also called contact metamorphism, and contact metamorphism is just a metamorphism with excessive heat. The country rock or the surrounding rock gets cooked by the heat of that intrusion as it's cooling. So the example here is, it's in the middle of Maine, and it is a Pluton in the middle of Maine. And you see around that Pluton, well, I can do it here, around this Pluton is the rock type Hornsfels. And Hornsfels is a non-foliated metamorphic rock just from heat. And in cross section here, then there's that granodiorite Pluton. We haven't talked about granodiorites, but we've talked about diorite and granite, so you can imagine it's somewhere in between. A granodiorite Pluton intrudes into that country rock, which was slate, and cooks the edges and makes Hornsfels. Burial metamorphism is just one step beyond lithification of a sedimentary rock. When all those clasts get deposited and more on top of it, more on top of it, more on top of it, there is a pressure that's going to occur and can make low-grade metamorphism of those sediments. Dynamic metamorphism for dynamic, I can't find a place for my face. Dynamic metamorphism occurs when there is fault movement that happens suddenly, and that sudden fault movement creates a rock type called myelinite. It takes the original rock that have equant crystals in it, and when that fault moves, those minerals get kind of strung out and sheared into tiny grains. That alteration is going to occur really quickly, and makes the rock type myelinite. Dynamic metamorphism. The next kind is regional metamorphism, and this one's the one that's the most widespread, regional. And it occurs when there is a continental collision. So at a convergent plate boundary, the plates come together, close up an ocean basin. That's the before. After that ocean basin closes and the plates continue to collide into each other, there's lots of fault motion. That fault motion creates stacks and stacks of thrust sheets. We'll learn about thrust next week. They're just a way to accommodate strain when there is compression. It's going to stack up those thrust sheets and cause a big mountain chain in the middle. Some of that rock gets buried, some of it gets sheared. So it's all temperature ranges, all pressure ranges are going to create lots of metamorphic rocks in mountain chains. And this is what we have all throughout the Appalachian Mountains is regional metamorphism. This is like the map we looked at with the index minerals where all of New England has metamorphic rocks, and those rocks are regionally metamorphosed. The next is hydrothermal metamorphism. Another word for this is metasomatism. And metasomatism happens when really hot water is going to circulate through some cold rocks. So in this diagram is a divergent plate boundary, and those are basalts and gabbros. Cold water comes from the ocean down through the cracks in those rocks, hits that hot, like magma chamber or the hot area around that. That hot water is able to dissolve minerals and carry around different ions, and it changes the chemistry of those basalts. Subduction zone metamorphism. This one is a metamorphism that happens kind of in conjunction with or just before there's that plate collision that makes regional metamorphism. So we oftentimes find blue schist facies rocks that are incorporated into mountain chains. So this has a very low temperature, but a very, very, very high pressure from that subduction zone. The blue in the blue schist is going to be turn my face back on. The blue in the blue schist is the mineral glaucophane that occurs during that compression. Blue schist facies. Those are the amphiboles get altered. Shock metamorphism occurs when there's an impact. So a asteroid comes in and hits the Earth, and then it changes the minerals. There are, for example, quartz gets changed into the mineral stishovite. So it reorganizes the SiO2, the silica, and the oxygen into a new mineral stishovite. So there's some shock metamorphisms. There's also glasses that occur during shock metamorphism. So that's the last kind of metamorphism.